Let's study about key transposition ciphers. Here we divide the plain text into groups of predetermined size called the blocks, and then use a key to permute the characters in each block separately. Let's take an example where Alice sends the message enemy attacks tonight. Alice and Bob agreed to divide text into groups of 5 characters and then permute the characters in each group. So if the number of characters in each group are not the same, then we add a bogus character at the end to make the last group to the same size as the others. We see in this plain text that in the last group there were only 5 characters, and hence we add Z, which is the bogus character. The key used for the encryption and decryption is a permutation key, and we see that there are indexes for each and every key. As we can see, the ciphertext has been mapped, and Bob divides the ciphertext into 5 character groups, and using the key in reverse order, the plaintext can be obtained. Decryption can be performed by multiplying the ciphertext by inverse key matrix to get the plaintext matrix. This is, as we see, this is the inverse key matrix, and this is the plain matrix. The plain matrix is multiplied by the inverse key matrix to get the ciphertext. Next, we check the cryptanalysis of transposition ciphers. As we know that it is only vulnerable to ciphertext only attacks, we consider the possibility of a statistical attack. Transposition cipher doesn't change the frequency of the letters, it only reorders the letters. So a single letter frequency analysis attack can be done. But these transposition ciphers can be useful when the length of the ciphertext is pretty long. Transposition ciphers do not preserve the frequency of diagrams and trigrams. If a ciphertext doesn't preserve the frequency of diagrams and trigrams, but does preserve the frequency of single letters, it is probable that cipher is a transposition cipher. Let's check the keys. The procedure to create a decryption key if an encryption key is given. First step is we add the indices to the key table. As we see in this table, we add indices 1, 2, 3, 4, 5, 6, 7, and then in the second step we swap the contents and the indices. We are swapping the contents and the indices. The indices are put in the box, and the rest of them are put outside. As we see in the fourth position, it was mapped to 4, and hence we sort the pairs out. And as we see, 1 was mapped to 2, and hence it was mapped to 2. Similarly, this is performed for all other pairs. Using matrix, we see that we can use a matrix to show encryption and decryption process for transposition cipher. The plaintext and the ciphertext are 1 cross m matrices representing numerical values of the characters. The keys will be square matrices of size m cross m, as we have previously seen. Encryption can be performed by multiplying the plaintext by key matrix to get the ciphertext. We now check the possibility of a brute force attack. Eve can try all possible keys to decrypt the message. Eve here is the intruder, but the number of keys obtained will be very huge. Mathematically representing, we can see that it will be 1 factorial plus 2 factorial plus the sum until L factorial, where L is defined as the length of the ciphertext. A better approach can be to guess the number of columns. If the ciphertext length is 20, then the number of columns will be a combination of the factors. The factors, as we see, are 1, 2, 4, 5, 10 and 20, where 1 and 20 are pretty unlikely. We now check the possibility of a pattern attack. Ciphertext generated from key transposition cipher has some repeated patterns. As we see in this example, we have different number of groups. There's a pattern in the above list. As we see, we have 5 groups. In all groups, the difference between two adjacent numbers is 5. This regularity can be used by a cryptanalyst to break the cipher. We now check another type of transposition cipher, which is a double transposition cipher. As we can see from the name, all we have to do is repeat the algorithm used for decryption and encryption twice. Different or the same key can be used in each step. As we see in the flow diagram, Alice provides the plain text along with the bogus character Z, and then row by row permuting the character, we get an intermediate text. This intermediate text is again permuted row by row to obtain a final ciphertext. This final ciphertext is being sent and then the receiver obtains this final ciphertext. Row by row it is being permuted, and intermediate text is obtained, which is pretty similar or exactly similar to the encryption performed. And then column by column it is being permuted, and then the plain text is obtained. As we see in the first step, row by row it was permuted, intermediate, and then row by row we permute the columns. Here row by row columns are permuted, and then row by row columns are permuted again. And this is how double transposition cipher basically works. Stream and block cipher are now checked out. Encryption and decryption are done one symbol at a time. As we see in this flow diagram, the characters in the plain text are fed into the encryption algorithm one at a time, and the ciphertext is also created one at a time. The key stream can be a stream of predetermined values, for example, an additive cipher, or the values may depend on the plain text ciphertext characters, which is basically a monoalphabetic substitution, or it can also depend on previous key values, or it can be created one values at a time using the algorithm.